Hey, welcome back. We're working with mixed numbers here, and there were two methods. We are going to skip the first method and I'm just going to teach you the second method because I really don't like working with mixed numbers, and I think you'll find the more you get up to higher classes, you're not going to be using mixed numbers. You're going to be using improper fractions. So we're just going to skip that. We're going to jump to method 2. Okay. So it says method 2 for adding or subtracting mixed numbers. Change the mixed numbers to improper fractions, and then follow the rules for adding and subtracting fractions. Change back to mixed number if necessary and reduce. So the shortcut, if you have like 3 and 5/4, no, that's not right, 5/6. How do you convert that to an improper fraction? Do you guys remember? Well, you're going to multiply 3 times 6, and then you're going to add the 5, and you're going to keep the denominator the same. So what's 3 times 6 going to be? That's going to be 18 plus 5 all over 6, which equals what? 23 over 6. Okay, so all you do is you multiply the denominator and the whole number, and then you add the numerator to the top, or to whatever you get for that, okay? So let's go ahead and do A here. So we have 5 1/4 minus 2 1/2. Well, we're going to convert them to improper fractions first. We have 5 times 4 plus 1. What's 5 times 4? That is 20. And what is 20 plus 1 going to be? That's going to be 21 over 4. Minus, and then we have 2 times 2 plus 1. What's 2 times 2? That is 4. And what's 4 plus 1? That's 5 over 2. Now we go back to what we did when we first learned all this stuff. We need to make sure we have a common denominator when we're adding or subtracting fractions. Do we have a common denominator here or no? We do not. So what's a common denominator? Remember, we start with the biggest number. We see if that number divides by the two numbers. Does 4 divide by 4 and 2 nicely? It does. So 4 is going to be our common denominator. So now we're going to do 2 times what to get to 4? 2 times 2 equals 4. So now we have 21 over 4. Minus 5 times 2 is 10 over 4. And what's 21 minus 10 going to be? Now we subtract the top to keep the bottoms the same. So 21 minus 10 is 11. And keep the denominator the same, 11 over 4. I'm going to keep 11 over 4 an improper fraction because I don't care about mixed numbers and I don't care who knows it. So yeah, deal with it, guys. Just kidding. All right, sounds good. Now we're going to get into multiplying and dividing mixed numbers. It's the same thing, change them to improper fractions, and then we're going to do what we did before. So let's get into it. Let's do it. All right. So convert these to improper. Actually, why don't you guys try these on your own? Pause the video, see if you can give these a try, and then I'll go over them really briefly, really quickly. All right, let's get into it. So we have 3 1/2 divided by 4 3/4. Well, let's convert to an improper fraction. So we do 3 times 2, and then we add 1. So 3 times 2 is 6. 6 plus 1 is 7. So we have 7 over 2 divided by, what's 4 times 4 plus 3 going to be? 4 times 4 is 16. 16 plus 3 is 19 over 4. All right. Now we need to get a common, no, we don't need a common denominator. Sorry about that. It's dividing fractions easy as pie. Flip the second and multiply. Or keep, change, flip, right? Keep, change, flip. All right. Now before we multiply, we always want to see if we can reduce the fractions. Can we reduce 7 and 2? No. 4 and 19? No. 7 and 19? No. 2 and 4? Yep. 2 goes into 2 how many times? 2 goes into 4 how many times? Twice. So we have 7 over 1 times, 2 over 19. And now it's multiplying fractions, no big problem. Top times top over bottom times bottom. So what's 7 times 2 going to be? That's going to be 14 over what's 1 times 19? That's 19. 19 is a prime number, so there are no numbers that go into 14 and 19, so besides 1 and 19, so our final answer is going to be 14 over 19. How'd you do? Did you get it? Hope you did. All right, next one, number 2. 2 2/3 times 1 3/4. We have to multiply 2 times 3 and add 2. So 2 times 3 plus 2. What's 2 times 3? That is 6. And 6 plus 2 is 8. 8 over 3 times. Then we have 1 times 4 plus 3. What's 1 times 4? That is 4. And 4 plus 3 is 7. We have 7 and keep the denominators the same when we're doing this little trick. And then it's multiplying fractions, no big problem. Top times top or bottom times bottom. I was going to show you, you don't need to reduce. You could also do this. What's 8 times 7? Let's just do this really briefly. That's 56. And what's 3 times 4? That's 12, right? So you could reduce it afterwards. What number goes into 56 and 12 nicely? I think it might be, let me just double check here. Yeah, I think you could divide these both by 4. And you could get 14 over 3. Oops. Which is the right answer. You can do it that way if that's more comfortable for you. It's just easier to reduce first. I'm going to rewrite it down here and do it the other way too. The reason why we do that is because it makes it easier to multiply in our brains and to reduce in our brains. It's easier to reduce the smaller numbers than to reduce like 8, 56, and 12, wouldn't you say? Okay, let's think about this. 8 and 3. Can we reduce 8 and 3? No. 7 and 4? No. 3 and 7? No. 8 and 4? Yep, 8 and 4 are both divisible by 4. 4 goes into 4 how many times? Once. 4 goes into 8 how many times? Twice. So we have 2/3 times 7 over 1. See, that's much nicer to work with, don't you say? That's like a lot easier to multiply and to reduce. What's 2 times 7 going to be? 14. And what's 3 times 1? So by reducing beforehand with the smaller numbers, it makes it easier to get the big numbers out of the way. You know what I mean? So, all right, you got through your first lesson of high school if you're a freshman, and most of you guys are, so way to go. Please watch these videos and take your notes and stuff, and then we'll be going over more. I'm not going to make you watch these in class. I'm going to be teaching it to you briefly in class, and then we'll have you watch the video afterwards and kind of learn that way. It's better for me to teach it to you in class than to just have you watch a video. That's kind of, I don't want to be a lazy teacher, so. All right, well, I'm not saying everybody's lazy, but anyways, it's been a long night. It's Sunday nights, and it's been a long time. But you guys have a great night, and we will see you in class.